Ladies and gentlemen, let's get started today. So what you're going to do with this activity is you're going to open up significant digits and measurements. On your screen, it should look something like this when it pops up here, student view. You'll open up the forms activity and you're going to walk through each step. We're going to do part of this together to help you out, and then you're going to have a chance to finish it up on your own. So on yours here, when scientists use an instrument such as a ruler or a graduated cylinder, the scientist can only measure as accurately as the instrument will allow. There's a proper way to record valid measurements from any instrument, which includes numbers that are considered significant. The purpose of this activity is to learn what digits are significant when recording a measurement. So first, we have this Econo ruler. The ruler shown below does not have very specific markings on it. What measurements or distances can you be certain of for the length of the tile? This means that you absolutely know that those numbers are present on the ruler. Phrase your answer using the sentence frame provided. I can be certain that the length is between blank and blank. So on your spot here where it says your answer, you're going to type in a complete sentence that says, I can be certain that the length is between, well, let's see here. I know that it's greater than 0. I'm looking at the tile down here at the bottom. This is my tile. I know it's greater than 0, but I know that it's less than 5. Those are the only two markings that I see. So in my box for number 1, I'm going to write out a complete sentence that says, I can be certain that the length is between 0 and 5 centimeters. This is a centimeter ruler. So now we're going to move on. Oops. Scroll here. Some students were using this ruler and they found different values for their measurement. Their readings were, so Sally, James, Tony, Maria, and DeMonte all measured that object and they found measurements of 3, 2.5, 3.5, 2, or 2.8 centimeters. What's the name of the mathematical or scientific technique that the students used to arrive at their values? And again, you're going to fill in the sentence that I gave you. The students arrived at their value by estimating the length of the tile. They're using that scientific skill of estimation to come up with the value. So for number 3 then, which student do you think has the best answer and why? Your job on this question here is to tell me which student do you agree with most. You can phrase your question as I agree with blank because. Now there's more than one right answer here. What I care about is that you can make a choice and that you can justify your response, that you can use some sort of scientific knowledge to say which student you think has the correct estimation. Then we're going to move on to part B. And if you're watching this video and filling in your form, make sure that you're pausing as necessary so that you can type your responses in. Now we're going to get a better ruler. We have the basic ruler shown below. What distances can you now be certain of that you were not certain on the Econo ruler? Again, you're going to use the sentence stem. I am now certain of the distances. So what kind of tick marks do we have here? Well, I see that I have 0 still, and I have 5, but I can be more precise because now I see tick marks every centimeter. So now I can be certain that the distance of the tile is between 2 and 3 centimeters. I have centimeter markings. So on your page, make sure that you type out a complete sentence to tell me about the fact that I have centimeter markings. I can be sure that my object is between 2 and 3 centimeters long. Again, the students are recording their different measurements. I have Sally, James, Tony, Maria, and DeMonte, and they found measurements of 2.5, 2.75, 2, 2.3, and 2.4 centimeters. Were they able to agree on a single value for any digit? If yes, what did they agree on? Well, if I look at these measurements here, every student has a 2 in the ones place. All of them start with a 2 in the ones place. So your complete sentence should say they all agree that there is a 2 in the ones place. So the next question then, what feature of the ruler made that possible? Well, let's scroll up and look at my ruler. How do I know that it's 2 something centimeters long? Well, I know that because the ruler has centimeter marks. So the feature is centimeter marks. Make sure that you write a complete sentence to explain your response. There will always be uncertainty in any measurement when using a scientific instrument. This causes variation in measurements even when using the same instrument. Compare the measurements made with each ruler. Which ruler, the Econo or the Basic, resulted in greater uncertainty and variation in measurements? Why is this the case? Well, if I look back at my rulers, this first ruler I had guesses as small as 2 centimeters and as large as 3.5 centimeters. So that's a range of 1.5 centimeters. Using my Basic ruler, my smallest value is 2 centimeters. My largest value is 2.75 centimeters. So this one has a range of 0.75 centimeters, less than a centimeter. So my second ruler, my Basic ruler has less variation because it has more precise markings. My Econo ruler has less precise markings, which means it has more uncertainty in its measurements. Make sure that you use your own words to write a complete sentence in the box. And then we're going to get one more ruler, a better ruler, the best ruler. I can see my object still. It's the same object measured with a new ruler now. Sally found a measurement of 2.72 centimeters. James found 2.75 centimeters. Tony, 2.73 centimeters. Maria, 2.7 centimeters. And DeMonte, 2.752 centimeters. What value were all the students able to agree upon this time? Well, if I look at those numbers, every student starts with 2.7. Each of the recorded measurements, 2.7, 2.7, 2.7. So they were able to agree on the 10th place this time. 2.7 was the agreed upon value. What feature made that possible? Well, if I look at my new ruler here, I can see the centimeter marks that I had on my Basic ruler, but now I see that each centimeter has been broken up into 10 pieces. 1/10 of a centimeter I can represent with my point blank, that's the 10th space on my number. But I can also call it a millimeter. A centimeter broken up into 10 pieces, while each piece is known as a millimeter. So the feature of the ruler is that the centimeter is broken into 10 parts, or that I can see millimeters. Make sure you use your own words. Write a complete sentence in the box. So now that I've practiced with these different rulers, now I need to figure out which measurements are valid and which ones are invalid. So the measurements shown on the Econo ruler are compiled below. The measurements that follow the rules agreed upon by scientists are in the valid column. Those that do not follow the rules are in the invalid column. In everyday language, valid means correct and invalid means incorrect. So if I look at these here, what's the difference between the valid and the invalid measurements? Well, my valid measurements are 2 centimeters or 3 centimeters. My invalid measurements are 2.5, 3.5, or 3.8. So what we should notice is that my valid measurements are a single whole number. It's just the ones place. My invalid measurements have the 10ths place. Make sure you write that out. Explain it in your own words in a complete sentence. Then I did the same thing with the Basic ruler. The measurements that follow the rules are in the valid column. The ones that do not are in the invalid column. Well, this one here, I see that 2. 2 was valid when I was using my other ruler, but now it falls in the invalid category. My valid measurements, 2.5, 2.3, and 2.4, compared to my invalid. So this one here, we're just going to look at that first invalid measurement. What I notice is that the valid measurements have just the 10th place. That first invalid measurement has a digit in the 100th place. Number 12 asks me to think about that second invalid measurement. Well, my second invalid measurement doesn't have that 10th place. It has just my integer value. So if I'm thinking about it here, the first invalid one is too precise. It's more precise than what my tool can read. My second one is not precise enough. I can be more accurate than just the integer value. So now let's move on to our last ruler, our best ruler. My valid measurements look like 2.72, 2.73, and 2.75, whereas my invalid measurements are 2.7 and 2.752. Again, I want to think about what my tool can measure. So that first one is invalid because it's not precise enough. I know that it's 2.7, but I can tell that it's 2.7 something. It goes past that 2.7. For number 14, the second invalid measurement is too precise. I can't tell that thousandth place based on the tool that I have. So when I'm looking at these measurements now, in all of the examples of valid measurements, no matter the ruler used, a part of the measurement was estimated. This will be true for any scientific instrument you use, like a graduated cylinder or a triple beam balance. Each valid measurement included one estimated digit. Every time I had one digit that was estimated. In a valid measurement, the estimated digit was always that very last one. The first digit I could agree on. The second to last I could agree on. It was the very last one. I always want to read one digit past what my tool is capable of reading. In the valid measurement, the estimated digit depended on the number of marks on the ruler. I wanted to look and see how precise my tool could be, and then I would go one step farther. Well then, the most precise instrument we should be able to tell. I'm not going to give you the answers to the rest of these here. Your job is to finish out this assignment after you've typed in all of your responses, and I want you to pay careful attention when you get to 22 and 23. These are the two questions that really let me know that you understood what we did here. The first one, we're using that basic ruler. Make sure that when you are recording your answer, you're giving me the proper number of significant digits. These are centimeter marks, so you are measuring the length of this object to the correct number of significant digits. Then you're going to do the same thing. We've got a different ruler next to the object now. Use the proper number of significant digits to record your answer here. Get this done. It is due by midnight tonight, ladies and gentlemen. Thanks for working hard.